Ladies and gentlemen, the tiny DevOps guy.
In this episode, we're going to talk about trunk-based development, what it is, what it isn't, different variations, techniques to use it. But before I dive into that, I want to give a quick update on the podcast. If you're a regular listener, you've noticed that I've been on hiatus for a while. I had a holiday come up. I had an office/studio renovation come up. I've had life come up, essentially. But I'm excited to announce that I'm back in the saddle again, and I have some exciting episodes in the pipeline. This episode you're listening to was recorded during my office renovation, so the sound quality may be lower than you're expecting. The video quality is lower. If you're watching the video, you'll see that I'm sitting in a half-finished office. But I hope that won't detract too much from the content. A little background on the episode. Jason, my guest, reached out on LinkedIn to all of his connections and asked for people with experience with trunk-based development. And I thought that could make for a very interesting episode. So I invited him on. He was excited to join. So that's what we talk about, is just trunk-based development, some of my experiences, different techniques to use trunk-based development. So I hope you'll find the episode interesting. If you have a question you would like to bring onto the show, I'd love to hear from you. You can find my contact details at jhall.io/contact. If you have a topic that would be of general interest to the audience, or maybe you have a topic that you'd like to talk about, but it's really very specific to your situation and wouldn't make for a good episode, I'm happy to talk to you about that too. Go to jhall.io/call, and you can borrow my brain for an hour. It's less expensive than you might think. Without further ado, let's jump on over to the interview. Jason, welcome to the show. We've been connected on LinkedIn for I think a few months, and I always appreciate your content. You always put a thoughtful twist on everything that you post. So just want to shout out to you on that. Thank you for making LinkedIn a better place. Would you tell our guests, or I'm sorry, would you tell our audience, you're our guest, would you tell our audience a little bit about yourself, what you do, and why we're on today to talk about trunk-based development?
Yeah, sure. I come into like the kind of the development world from a non-traditional background. I didn't study computer science. I didn't go to a boot camp, anything like that. I started off. I studied biology in undergrad, and I worked in marketing and business development, and got really bored of that. I moved into analytics and data science, I guess, before it was called that buzzword, and just kind of navigated further and further towards like the software development, software engineering side of things and automating, and then just kind of like took the full plunge. And 2 or 3 years ago now was like really just I just went full bore for that and left the data science and analytics stuff behind. I still
Okay.
kind of leverage that when I have to, but yeah, that's kind of how I ended up here. I currently work at a startup that's building a pretty cool app around connecting personal trainers with clients, and doing a bunch of Golang based development. But
Cool.
I'm really interested in some of these concepts I've seen that have been around a long time, and like how I can like practically take them into like a team setting for people who haven't even maybe even heard of them or done them. So that's kind of like the space I'm coming from in this episode.
That's great. So now at the moment you're doing software development yourself, right?
Yeah, right now it's a very small team, so I'm just an individual contributor. I actually enjoy that. I'm kind of like, I guess, like old for the tech world. I kind of got into it. I didn't get into my 30s, and so
Yeah.
I'm kind of like an old guy in that regard. But I really enjoy the like individual contributor aspect of like here's kind of like a hard problem, or here's some like complex flow or some complex business logic we need to map out. And like how do we go about doing that? And yeah, I kind of like learned about myself that I like to lead from the front and not necessarily be a people manager. And so it's a good fit for me, yeah, in that regard.
Great. So the initial question. Now I know before we started recording, you said you had more than just one question, and that's great. We can talk as long as you want. But your initial question, the one that sparked this episode on LinkedIn, was about trunk-based development. Do you want to describe the way you're doing branch management right now,
Sure.
and then we'll talk about trunk-based.
Yeah, so the way I'm doing it now is kind of the way I was taught. I don't know, a few jobs ago now. Kind of like the first job I had where I was like in some sort of like role where I was actually coding, and it was going into a production application and stuff like that. And It's the kind of like, I guess, Git hub flow, or kind of some sort of like modified Git flow or GitHub flow, where you have a main branch and we have feature branches coming off of that. And then the feature branches can get deployed into like a lower environment for testing. And then when the PR is, fully completed, then we can merge it into main and have, some pipelines kick off to do a production deploy. So that's kind of been the general flow, some variations of that over the last few years. And I keep running into like bottlenecks, like constant bottlenecks. And so I even see a lot of people online like, hey, trunk-based development is like that plus, several kind of other ideas or methodologies together can be like really, really fast, incremental, highly tested software. So I've been trying to educate myself on those things, and I don't know, try to bring my skills up to a level where I could feel comfortable taking it to a team and be like, hey, let's try this out.
Nice. So it sounds like at the moment you have two long-lived branches, main, and I don't know what your other one's called, develop probably, or stage, something like that.
We don't even have that. So we really, now we just have main, and we feature branch off main. We try to keep it small. And my understanding of the stuff I've read about trunk-based development is like, you can do that, but it needs to be really, really short-lived. But the preference is to just be confident that your commits to main or trunk are tested and validated.
Awesome. So actually, it sounds like you're not as far away from trunk-based as maybe I initially thought. So just for context, and anybody listening, if you're familiar with this workflow, a full Git flow usually has 2 or sometimes 3, maybe even 4 long-lived branches. So you have main, or sometimes called production, where your production code is rolled and deployed. And then I'll just simplify for the sake of conversation right now, but you could have many stages. But usually we'll just say 2 for today. Then there's a develop one. So usually make a branch off of develop, make your changes, and then you merge back into develop. That gets deployed potentially to a staging server or something where maybe QA people run tests against it or whatever. Once you're confident that you're ready to merge, then you either merge your feature individually again from that branch into main, maybe with cherry picks or something, or maybe you merge the whole branch all at once if you harden the whole thing together. So GitFlow has the multiple stages with each long-lived feature branches. So you're already a step closer to trunk-based than that, which is going to probably make the transition easier. But it sounds like you have long-lived branches. How long do your branches typically survive? Are they days or weeks or even longer?
Typically days. Yeah, we try to keep the scope relatively small, so that there's not as much cognitive load to review, and you're not pushing as big a change that could potentially have unintended side effects, and it's easier to test. Yeah, that's kind of the thing we're doing now. I had done that where we had multiple long-lived branches, like a main, a dev, even a staging or pre-prod or something like that. And that just, it was awful, because it's just like there's so many branches and they get out of sync, and then multiple pipelines are running into each other, and you're on a waiting list to QA stuff in an environment, and it's just like I kept feeling like there's got to be a better way. Like, this is so slow. So that's kind of what has pushed me this way.
Probably the next step here is to define what trunk-based development is, and there are 2 flavors of trunk-based development. And I think what you're asking about is the pure flavor, which is where you kind of just commit straight to trunk without pull requests at all, without feature branches. So let me talk about that first, and then I'll talk about the sort of less pure version, which is kind of closer to what you're doing. So I don't have a lot of experience with pure trunk-based development, and there's a simple reason that I'll explain in a minute. But the teams that do it, the way they do that, it usually works. I think it works better on smaller teams, but I suppose if you're disciplined enough, it could work on a larger team. Usually you do it with pair programming. So you have 2 people sitting at the keyboard together. You pull down, you update master, so you're at the latest version. You make your changes probably over the course of 20 minutes to an hour. So it's a fairly short session. You have something incremental that works, and you push it to master. And at that point, a CI/CD pipeline type thing kicks off and runs tests against master. If you have somehow accidentally broken master, now hopefully everybody's being completely disciplined and they're running their tests locally before they do this, and there's never a risk of breaking master. But sometimes maybe you break master accidentally. it goes red, and then basically the whole team stops working until master's working again. So hopefully that only happens once every few weeks or something. But that's the theory behind the so-called pure trunk-based development. So you're literally pushing to trunk, and if you push and there's a conflict, then you do a rebase or something and try again until it works. So that's the pure trunk-based development. What I think most teams do, at least first, and this is what I usually do, is it's more like what you described, but with short-lived feature branches. So I still branch off of master, and I still create a pull request. But I often, those pull requests maybe only take me 10 minutes, and then I create a request. So it's a very small amount of work. And then it maybe goes through review or maybe doesn't, depending. If I was pair programming with somebody, I probably wouldn't go through a second review process. I would just let the tests run and then merge. But and this is the reason I prefer this approach, although many people disagree with me, and that's fine. There's room to disagree. The reason I prefer this approach is I like the confidence that my tests have passed before I merge to master.
Yeah.
And with a pull request, even if there's no human actually manually reviewing the code, at least I know that my tests are passing. Of course, that's only useful if you have tests.
Yeah.
And if you're in a project that doesn't have tests yet, then there's no assurance there either. So broadly speaking, those are the two flavors of trunk-based development. One is pure trunk-based development, going straight off of master or main or trunk, whatever it's called. And the other is this sort of short-lived feature branch version. And it sounds like you're kind of in a long-lived feature branch version that's similar in principle. But I think the missing piece for you is what I would call continuous integration. And I don't mean a CI server. I mean continuous integration, the practice of integrating your code continuously, which I think Martin Fowler defines as integrating at least once per day. So if you buy that rule or by that definition, then the maximum time a feature branch should live is 24 hours or maybe 8 hours if you want to count work hours. So we can talk about that. I mean, I don't know if that's the way you want to go here. We could talk about strategies to make that easier
Yeah, I'm definitely interested in that because that seems to be kind of like that's kind of like the breakdown I've seen online was the two camps, kind of what you described. But the problem I've seen is like not just where I currently work. We do get some that go in a day, which are really short, little small scope on a branch. But us and teams I've been on in the past, we tend to feature branches can linger over days or even a week, and then you end up with this issue that someone else. There's already been several other things that have gone into main in that week, and so now you're pretty far behind, and you got to rebase and fix any issues and kind of go through this whole review process again. And I for one am a huge advocate for like pair programming because like I had a really good kind of mentor when I started programming that we did a lot of pair programming.
Nice.
And like I found that immensely helpful for like just thinking through and talking through how you're working on things. So that aspect of it appeals to me. Yeah, I'm definitely that in that camp. I think I like to see all the tests pass as like sort of like a safety measure before I cut the merge. One thing I am curious about, I don't know how this relates to that, but like on something going into like your main branch, like your production code base, we typically like will cut a release periodically, not like on a cadence, but like I don't know, once a day or something like that. If several merges go in, and we'll cut a new release, and then the cutting of the release will trigger a new pipeline for actually deploying to the production environment. So like there is even a safety check there that if I were to push something into main, it's not immediately going to the production applications. I don't know if that's what that's considered or not, but yeah, I'm curious to hear more about like what is like, because I see so many conflicting definitions of like what is CI, and so that's kind of like, I guess that would probably be a good starting place.
Well, yeah, why don't I walk through the rest of the traditional CI/CD pipeline and provide my definitions, which will differ from other people sometimes. I mean, I think the most important thing to start with is understanding that most of these define practices, not tools. Tools are there to enable the practices, and CI is a great example. Continuous integration it's all in the name, but we forget that all the time. It's about integrating continuously. I mean, if I go to a conference, I've done this a couple of times, and I'm speaking or at a meetup or whatever, and I ask a show of hands who uses CI. Like 80% of the room raises their hand. And then I say, how many of you have a feature branch that lived more than a day? And half the hands go down. And how many of you had more than one developer working on that code over the last couple of days? And hands go down. And how many of So I do that, and it turns out most people aren't actually doing CI, even though they think they are, because they're using a quote CI tool. So if you're not integrating regularly, which should be a minimum of once a day, if not 10 or 15 or 20 times a day, you're not doing continuous integration. However, and this is where the confusion comes from, to enable that, you need to be able to run your tests very quickly. I mean, if it takes an hour to run your test suite, or worse, it takes 6 hours to wait for the manual test developer guy to run through a bunch of manual test scenarios, there's no possible way to integrate that quickly. So that's where the confusion comes from, is we have a tool that has become known as a CI tool or a CI pipeline that enables us to do this continuous integration. The next step from there, usually, or logically, is continuous delivery, which is the name of Dave Farley's old book. I know you mentioned before the recording you're reading his new one. I haven't read it yet, but it's on my list.
Yeah.
But his old book was called Continuous Delivery, and it's a great book too. And it's about the idea that every time you merge to master, you build a deployable artifact. And this is really it sounds like you're close to this. Maybe it's not automatic, but you have a button, so it's at least easy. And the big advantage to this is you never run into a surprise that we're ready to release. Oh, but the release is broken for some reason. Maybe some dependency from npm changed, or something happened unexpected, and we can't release.
Sure.
So with continuous delivery, you have confidence that after every merge, within a few minutes, maybe 20 minutes, something, it's built an artifact, whether that's a Docker image or an APK you could send to the Google Play Store or whatever. Maybe it's not actually going anywhere, but at least it's ready, so it could go somewhere.
Oh, that's cool. We actually do that. So, yeah, that's exactly how our main merge setup is. So any merge to main builds a Docker image and saves it in our image repository on AWS, and then it doesn't actually get deployed unless we trigger the release.
Okay.
So we sort of do it.
Yeah, it sounds like you're doing continuous delivery, but you're probably not doing the next one I'm going to describe, which is continuous deployment. And that's the idea that it just takes it one step further, and it automatically deploys as soon as the artifact is ready. And there are many business reasons you might not want to do that. An easy, obvious example that everybody understands is you're building a mobile app, and you have 100 developers, each merging 10 times a day, and you don't want to send 1,000 updates to your mobile clients every time you update.
Yeah.
So you probably want to batch those and not release until maybe the end of the week or the end of the month or something like that. So, and there are many other business cases too that you wouldn't want to do continuous deployment. But I honestly can't think of a single scenario where continuous delivery doesn't at least make sense, to at least practice the automatic art of building an artifact. I don't know of a scenario where that wouldn't make sense. So that's a really high level overview of kind of this software release pipeline architecture that you're probably hearing a lot of buzz about. I hope that helps break down the little pieces. And it sounds like you're actually not terribly far away from a good place. You're already doing continuous delivery, and you have an easy release process. So should we go back and talk about some of the strategies for making those pull requests smaller?
For the CI part of having your tests run, which to me is really what got me interested with coupling with test-driven development, because you kind of build that flow at the same time, and that's a good synergy between those two. Was that our CI tool that we're using, I've been trying to work on, dependency caching and some other strategies to speed up they're already pretty fast. Any commit takes 4 or 5 minutes to build and run the test, but I want it faster than that, because it's just nice to be able to commit really frequently and see things pass. And so that's something we're actively trying to cut down the times on to see those things faster, that feedback loop faster. But yeah, I guess yeah, I'd be interested in like how do we like maybe we say we like stick with this kind of like feature branching off of main. Like how do we trim down this, the scope or the units of work for, and some of that kind of like wades into project management territory, but like how do we scale some of that down so that like these feature branches are just going multiple times a day into main.
So I think you have to tackle this from multiple angles. There's no single thing you can do to solve this because it's an interwoven system. And let me just illustrate that with an example. Suppose that you magically, with a snap of your fingers, could, instead of creating one feature per day or one branch per day, could now turn that same work into 100 branches per day. You wouldn't be any faster because you'd be still waiting for somebody to review your code at the end of the day.
Yeah.
So yeah. You can't do this by yourself. It requires several angles. And also let me just jump straight ahead here that the smallest batch of work you can do in coding is a line of code that is reviewed at the same time it's written. In other words, pair programming. So if you or others on your team are comfortable with pair programming, that is an excellent way to sort of jump ahead of what I'm going to describe in a minute and get the advantage of this faster. But let's talk about some approaches I coach teams on and that I use myself for shorter and smaller pull requests, which I think naturally lead to the idea of pair programming, especially on teams that maybe don't like the idea. This leads to that because you get to a cadence where you're almost pair programming through GitHub. But I'm getting ahead of myself. So if you're doing TDD, you already have a cycle where your code is proven to work every few minutes at most. And every one of those times is an opportunity to create a pull request and ask for review and merge. Now, I wouldn't practically. I don't usually create one pull request for every green cycle in my red-green refactored cycle, but you could. Normally, I'm working on a function. Maybe I add a little bit of functionality that has 5 or 6 tests, and that becomes a pull request. But the point is that because if you're doing TDD, and I don't know if everybody on your team is, but if you're doing TDD, then you have checkpoints, frequent checkpoints that tell you it's safe to merge effectively, or it's safe to create a pull request that could be merged. So keep that in mind. The main thing is, though, just to merge smaller portions of functionality. Feature flags help this, although they're not usually necessary. I kind of keep those in my back pocket as last resort. Maybe you're already using them, but they're kind of heavy for this sort of thing. I like to just use an if false. If I have code that's incomplete, I just wrap it in if false. My tests can still run around it. I can comment out the if false for my testing, and then when I'm done, I just delete the if false. But that way I can have my code. It's integrated. So there's no risk of conflicts with other developers because it's already in their checkouts also.
I haven't done a ton with like feature flagging. Like my current company, like the feature flags we have typically are they're from the mobile side. So like our app is primarily an iOS app. And so they'll feature flag, accessing certain things on the back end or some new feature they want to expose to a subset of users. And we don't, I guess I didn't really preface this at the beginning. I primarily do like back end, server side development for some of our services that power the different applications we have. And so we haven't really done much at all with anything really with feature flags on our side of things. I understand the benefit. We did at my last job. We had some server side feature flagging as we wanted to try new things and roll out to certain percentages, but not in this current setup.
Yeah. I mean, you definitely can use feature flags on the back end, but like I said a minute ago, I tend to kind of keep that as last resort.
Yeah.
Basically, every time you do a feature flag, you're taking on technical debt, which is fine if you know that, but there's code you have to clean up later. And I worked at Booking.com, which is famous for their A/B test, and there was so much uncleaned up A/B testing and feature flagging code. It was a disaster. So it can spiral out of control very quickly if you're not very careful. So that's the main reason I keep feature flags sort of as a back pocket thing. When it's necessary, it's very powerful. For front end, it's a lot more power. There's a lot more reasons to use it. But for back end code, I tend to prefer lighter weight alternatives. But the point I was trying to make, I guess, is that you can and should merge incomplete features as long as they aren't broken. And so that, I don't know, maybe you're building up some new authentication flow or something. You could build, the middle part without the two end pieces first and merge that, and then add the end, and then add the beginning, and then bundle it all together. As long as the whole application continues to work with these bits of unused code. Where the feature flag or a simple if false is appropriate is when you start to wire the things up, but you don't want to actually expose it yet. So then that would be the place to use that. If you have a feature that's only going to take a day or two to build, a full-fledged feature flag is probably overkill. That's really more appropriate if you have something that takes maybe weeks or months, or involves multiple developers, or needs some extra sort of care or validation. But that's really the point I wanted to make is don't be afraid to merge incomplete features.
Well, that makes sense, because that's kind of like that tends to be like the part where I have a hard time delineating like where I should stop on something, instead of, because otherwise nobody wants to review a 1,000-line PR, because it's too much. I've been trying to push more. I read Eric Evans' Domaindriven Design, and I've been trying to integrate I had realized after reading that there were several strategies in there that I had already used or seen, but I didn't realize that's where they came from, like the repository pattern and things like that. And so I've been trying to kind of chunk up, let's say, a new feature, for example, like what you said. I'm actually working on some new payment flows for our application, and trying to chunk up the actual just pure domain logic layer, and then different unit of work for a repository layer, a different unit of work for handlers and stuff like that, and then stitching things. So I'm trying to sort of follow that.
Sounds like you're on the right track. Another piece I pulled out of Michael Feather's book, Working Effectively with Legacy Code. I think it's in the first chapter. He talks about 4 reasons to change code. He talks about adding a new functionality, fixing a bug, refactoring, so changing the structure of the code without changing its functionality, or performance improvements. So there are a few other reasons, and sometimes there's gray areas between these. But I like to use this as a general guideline to never do more than one of these in a pull request. So that helps keep your pull request small too. But what that means is if you're working on a new feature and you discover a bug and you're tempted to fix it in your same pull request, probably don't. Create a new pull request to fix that bug. And there's practical reasons for that too. Aside from it keeping your pull request smaller, imagine that your feature has to be reverted for some reason in the future. You don't want to revert that bug fix at the same time. So it's nice just to keep those separate for that reason.
That's a good point.
If you're doing if you're trying to do some performance profiling and fixing a performance bug, you don't want to, or not bug, but performance issue, you don't want to add new features at the same time, because that's going to confuse your results. So there's all sorts of good reasons to keep those 4 separate. But as it relates to this conversation, it's one dimension to think of to keep your pull requests isolated. I'm never afraid, or rarely afraid. I'm never afraid. Sometimes I'm annoyed, but I'm never afraid to cherry pick some things out of a larger branch to a smaller one. So this usually happens. This actually is a common example of I'm working on a new feature and I discover a bug along the way and I fix it, and then I later go, I should have done that as a separate pull request. Just cherry pick it out and create a new pull request, get that merged. Maybe my other one's still sitting there for another hour, but at least the bug fix is down to production, and then I can rebase it, and it just takes care of itself. So don't be afraid to cherry pick little bits. I also encourage, when I'm code reviewing, I encourage my colleagues to do this sometimes. If I see that they've touched 3 different files in maybe they're kind of related ways, but like one of them could very easily be its own pull request, to say, why don't you just cherry pick that out into its own pull request? I can read that faster, and get that out of the way, and then we can discuss the changes I want to discuss on these other ones, or something like that.
That's a good idea. My team lead has my boss has recommended that a few times because I have that, I end up with that problem sometimes. I say, oh, this code is terrible here, and I'm like, let me just fix this real quick, and it's not anything to do with what I was working on, and the typical response has been, hey, just yank that into a new one.
And that makes review so much easier, especially for something like formatting, or you're renaming some variables because they were all confusing or something. It's so much easier just to review a variable name change as its isolated pull request versus that and a bunch of functional changes at the same time. So that's a great one. Those are my top suggestions off the top of my head on how to keep pull requests small. But I think it's really important to keep in mind, as I said at the beginning of this part of the conversation, if you're the only one doing this, it's not going to really help. You're going to end up with a pile of pull requests waiting for review. So what I always do is, when I'm working on teams on increasing the flow, that's really what we're talking about here. Is we're not talking about more code. We're talking about increasing flow. So we need to think of it from a systemic standpoint and a sort of a flow engineering standpoint. What we need to do then is we need to come to a working agreement as a team that code review is priority. So my basic rule is, unless there's a fire, unless the database is literally crashing and servers can't log and customers can't log in or whatever, there's some sort of incident, code review is always the highest priority when you reach a breaking point. So you finish your task and you're thinking, what's my next task? See if there's any open pull request review. If there are, just review those. The pushback I get from this is, oh, but code review takes so long and it's boring. Yes, but if you do it this way, it's not. If everybody's making quick pull requests, you're just going to spend 5 or 10 minutes reviewing a couple 10-line changes, and you're probably just going to hit okay, or maybe you make a suggestion, whatever. It's going to be quick. So you feel like you got something done. You got through 3 pull requests in 10 minutes. That's fine. That doesn't feel slow and boring. It feels fast and quick. And then you go back and write another pull request. So you have to make that your priority. Unblock your colleagues before you work on your own work. Needs to be the rule of the team. And like I said, if you do this well, and you get to the point where you're making 4 pull requests in an hour, and your colleagues are reviewing your 4 pull requests in an hour, pretty soon you're going to get to the point where, like, why don't we just sit down at the keyboard together and do this together? and your pair programming at that point.
Yeah, that makes sense. No, that's really helpful. Yeah, we're trying to. Our team struggles with that a little bit. We get pull requests that are stale, or people won't review them, or it's just elongated, even if it's a simple one. And so we've set up some GitHub's Slack integration has some pretty handy little helpers that will do constant reminders, like, hey, there's PR open. It's been open for a couple hours. It's waiting on you. Like, go review it. And so we're trying to put some of those things in place to just make it a little easier to remember to hop on when you have a second and give someone's PR a quick review. I think it's starting to get better. The team itself is like pretty new, so I've been there a few months now, and all of us have been started within the last 3 months. So other than the team, like the team lead, our boss, like she was there for the last year, and the team, it was basically just her after some developers left, and then took some time to hire back some new people. So the team is all kind of just trying to like get our bearings on like what's the right way for us to do this stuff.
So I guess one other thing, if you have a pull request, it's taking too long to be reviewed, you're tired of waiting for it, cherry pick something out of it, make it smaller, and your colleagues will be grateful that you have a smaller pull request.
That's good. That's a good idea. I'm gonna start doing that. I'm still like, reading. I think I'm planning on taking, I got like a stipend at work, so I'm planning on taking Dave Farley's TDD course.
Nice.
Because like I know this is like not quite related to the trunk-based development. It sort of is. I think like I think the TDD stuff like goes pretty like synergistically with it. I sort of do like what I would say is like a knockoff version. I don't quite write the test first, but like I write like interface stubs that don't do anything, and then I write tests based on those stubs, and then I fill in the implementation. So I almost do it. So I'm trying to like, I want to take some courses to like get actually to the next level of like the test driven design portion of it.
Yeah, I mean, I agree with you that test-driven development does closely relate to this. I mean, you can do all of these things without TDD, but I think TDD, my experience is it makes it easier and faster, um, which is the reason I prefer TDD. I feel like it gives me a performance boost. I know that there are people who think that uh, it's a waste because you're writing tests that you may not quote need. Um, but I need those tests. I mean, they're telling me that I'm doing what I think I'm doing, and I'm not writing code down some rabbit hole. So that's another topic, but I do agree with you that it's closely related. It is synergistic, as you say. It's a good practice to do with these other things. But I don't want to dissuade. If anybody out there hates TDD, I don't want you to think that you can't also do these other things. You can do these without TDD also.
I never realized how upset people get in the tech world over like, do this, don't do that.
I guess it feels personal when somebody's telling you how you should cook your own food in your own kitchen. But
yeah,
yeah,
it's a fun.
I want to learn how to cook the best way, whether it's my way or
right.
not.
That's how
I want to learn the most effective way.
One thing I've been interested in is I guess this sort of does relate to this in terms of like CI/CD pipelines. I'm a big fan of like infrastructure as code, and so I always wanted to. In the teams I was on in the past, worked really hard to bake in infrastructure as code checks, or the automated deployment part of it on a push to main via the infrastructure as code. What's the is that something you typically recommend to teams? Again, it's not like I'm not married to a tool, but like the process of that, it's not something that's like easy to test or validate, I guess, until it actually tries to do it. So that's something that I found to be kind of a tricky until you get the initial infrastructure as code set up. Like how does that work in like a continuous like a CI environment? How does that piece work? Say for example, like our thing we talked about before, we're like continuous, not deployment, but I forgot, what was the other D we talked about? Continuous
Delivery.
Delivery, yeah. That like
Yeah.
we have these buildable artifacts. How does like IAC fit into that?
So infrastructure as code, I mean, it can fit in at different levels. You could deploy your entire data center with infrastructure as code in theory.
Yeah.
Right? You could set up Terraform or something that goes out and sets up your EC2 instances and your S3 buckets, does everything for you at that level. It's kind of hard to do automated testing for that. You can to an extent. Like you could deploy it and then have some scripts that see, did we create the right number of instances of this, and do we have the right buckets there, and do they have the right permissions and whatever. It's probably not a very efficient use of testing, since especially if you're using Terraform, we can probably trust that the tool does its job and sets things up correctly. Where I have used testing and infrastructure as code together is like if I'm deploying to Kubernetes, maybe with a Helm chart. And I don't know if you guys do at your work, but that's kind of where infrastructure as code and testing they kind of merge in this confusing centerpiece of Venn diagram. So you can, in fact, there's tools that will let you test a Helm chart, and they test it by potentially by starting the Helm chart in Kubernetes and running tests against it that you've defined. So you could create a test that, it could be a bash script, for example, that checks to see that the right files exist in the right directories with the right permissions, and returns a true value or something like that. So you can go that route if you want to. It's kind of I would consider that kind of an advanced feature. Like I've only done that at one company, and we only did like the bare minimum version of it. We didn't set up complicated Helm tests. What I have seen more often is tests that will test like a Docker image to see that it doesn't have security vulnerabilities. Maybe run some static analysis or dynamic analysis against it. Checks that you don't have password files or SSH keys in there, things like that. So you could do that sort of testing as well. I mean, the truth is the sky's the limit when it comes to what kind of testing you want to do. If you can think of something to test, you can find a way to automate it in almost all cases. So, and it is good to do that for infrastructure as code, especially for the purposes of security. you don't want credentials or giving the wrong access to the wrong people and things like that.
Yeah, it's not something where we have just yet, but like all my previous roles were very heavy into IAC stuff, mostly Terraform, some other native like AWS tooling for that, but trying to push us towards that for some of the stuff we're doing now, because it's notoriously brittle to have to change or set stuff up in the GUI based thing on like a cloud provider. So and that just makes me nervous, and so it's something I think I could just automate it. I'd rather do that, so I don't have to worry about it. So but like, yeah, in the past I've just had it where it was part of the final deployment piece, was like maybe part of the commit, build, test part was just like a Terraform plan or something that just like validated that a plan could be, that the infrastructure could be provisioned in the way that you put it up, and then the actual provisioning happened only on the merge to main or something to that effect. Yeah, that makes sense. Well, cool. Yeah, I don't really have any other questions. I mean, again, I have like other topics I've been reading a lot about. I read Clean Architecture a couple of years ago, and I have been reading a lot about, like, I don't know, Hexagonal Architecture, which is sort of the same thing. They're all kind of the same name, but different names, the same topic, like
right.
Clean Architecture, Hexagonal Ports Adapters, whatever you want to call it.
Mm-hmm.
So I feel like there's a lot of synergy between those things, like domain-driven design and Clean Architecture and true CI, CD, and trunk-based development. So I'm trying to kind of like move on in all that direction.
Yeah, they're all tools designed to help us keep context so that we can think about problems in a useful way, to constrain context, I mean. So we aren't thinking about all the different problems at once. We're just thinking about one little bit. TDD helps with that. Hexagonal Architecture, microservices should help with that if they're done well. They usually aren't.
Yeah.
Et cetera, et cetera.
That's
so
true.
Yeah.
I did read an interesting thing from Uber on domain. They called it domain-driven, domain-oriented or domain-driven microservices, where they had, and we kind of did this at my last place, where we had a kind of a cluster of microservices that were pretty specific, but they were all within like kind of like, I guess, like what you would call a bounded context in domain-driven design. And so there was kind of like a centralized entry point and exit point for these services, but then they could kind of work together to do different things, and there were some kind of clear separations on what they were responsible for. That company was much bigger, so like that made sense. A smaller company, that's kind of overkill. It's a lot of overhead to build that out.
Right. Jason, thanks so much for coming on. If people are interested in connecting with you on LinkedIn, or I think you did, I assume you still do have a mailing list. How can people get in touch with you?
I'm on LinkedIn. I post sporadically on there, and then I have a site. It's called functionalbits.io, which I'm planning to kind of morph into. Right now, it kind of exists as a blog site, and I have like an automated newsletter I wrote that pulls a bunch of like tech, kind of like high quality tech blogs and research papers and repositories, and bundles them up in a email every day and sends them out. It's something I had built for myself on my Raspberry Pi to like just serve myself stuff every day to read. And I was like, well, I might as well just deploy it up on the cloud somewhere and see if other people would be interested in it. So I'm planning to put out a course sometime in the near future. I've been working on something related to like hexagonal architecture and domain-driven design and how I use those things to build like a microservice. So something small in that regard that I think is kind of like a missing piece of people learn like very basic stuff, and then like there's a lot of stuff missing between there and like these other concepts. And so through experimentation, I think I can help some folks like bridge the gap a little bit.
Very cool. Great. Well, thank you, Jason, for coming on, and hope to be in touch with you on LinkedIn soon.
Yeah, it's been great. Thanks, Jonathan.
All right. Cheers.